Okay, in this video, we want to find the derivative of this given function. Now, if we were to take a quotient rule approach, we would actually apply the quotient rule and apply the chain rule twice. So it's like a quotient rule, double chain rule problem. But I'm going to use a different method. I'm going to use a method called logarithmic differentiation. And that's where we use some algebra to simplify the calculus. So we're going to go ahead and the premise behind logarithmic differentiation is to start by doing this, taking the log of both sides. And I'll use the natural log because it has the simpler derivative. So we'll take the natural log of both sides. Okay, so we have the natural log of y is equal to the natural log of x minus 2 squared divided by the square root of x squared plus 1. Now, we could basically use the properties of logarithms to simplify. Okay, so we have a quotient. So the log of a quotient is equal to the difference of the logarithms. So we could apply that rule. Let's come down here on the left. So we have natural log of y is equal to, that's going to be the natural log of the top divided by the natural log of the bottom. The natural log of the numerator, which is x minus 2 squared, minus the natural log of the denominator. And instead of the square root symbol, I'm going to use the 1/2 power. Means the same thing. Natural log of x squared plus 1 to the 1/2 power. Now we have another property of logarithms. It says, okay, if there's an exponent on the argument, it can come out front. So let's pop the 2 and the 1/2 out front. Okay, so we have the natural log of y is equal to 2 times the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. Okay, so now at this point, we can take the derivative of both sides. So implicitly, the derivative of natural log of y is 1 over y times y prime, or we could just say that's y prime over y. Okay. And the derivative of the natural log of x minus 2 is 1 over x minus 2, and we have a 2 out front, so that will be 2 over x minus 2. So we're using the chain rule version of the derivative rule for the logarithms. So that's the derivative of the natural log of u is equal to u prime over u. Okay, so that's what we're applying here and here. Okay, so minus. So we have a 1/2. And the derivative of natural log of x squared plus 1 will be the derivative of x squared plus 1. Let's say 1/2 times u prime, which is 2x, the derivative of x squared plus 1, divided by x squared plus 1. And it looks like we could cancel these 2's. Okay, so let's get a common denominator and put these two fractions together. So we could, let's see, we can multiply x minus 2 over x minus 2 here, and we could multiply an x squared plus 1 and an x squared plus 1. Okay, so let's clean this up a little bit. We have y prime over y is equal to, see here, we've got 2x squared plus 2 minus, and here we've got a minus x squared and a minus minus 2x, so that's a plus 2x. And on the bottom, our common denominator is x minus 2 times x squared plus 1. All right, so our goal is to find the derivative, which means find y prime. So our goal is to solve for y prime, as we have a y here on the left. Let's get rid of that y. We can multiply both sides by y. We can do something like this, y on the right, y on the left. Okay, so what does that look like? Let's come down here. So we have y prime is equal to, and that's what we're looking for. We're looking for y prime. So y prime is equal to y times, well, let's see, we could combine some like terms here. Looks like we have an x squared, we have a plus 2x, and we have a plus 2. And on the bottom, we have x minus 2 times x squared plus 1. All right, so we have to get rid of y, and we have an expression for y. The original problem, y is equal to this. So let's take this original y and bring it down and replace y with this other expression. Y is a function of x. So let's make this green so we could distinguish. The y is the x squared minus 2 quantity squared divided by x squared plus 1 square root, or we'll say the 1/2 power. And we've also got the x squared plus 2x plus 2 divided by x minus 2. Oh, sorry, that square should not be there, just x minus 2 quantity squared on top. And so we have x minus 2 times x squared plus 1 to the 1/2 power. We could do a little bit of canceling here. This x minus 2 cancels one of these x minus 2's. And it looks like when it's all said and done, y prime is equal to x minus 2 times x squared plus 2x plus 2, all divided by x squared plus 1 to the power 3/2. We have the 1/2 power and the 1/2 power and the, this 1/2, sorry, this 1/2 shouldn't be there. So we have a 1/2 power from the expression of y, and we have the x squared plus 1. All right, so that about does it. That is logarithmic differentiation. We use properties of logarithms to simplify. We usually simplify an expression, a rational expression, maybe a rational expression that contains roots, and we actually sort of replace the we replace some of the complicated calculus with a little bit of algebra. And the derivative process is a little bit easier because this up here, this is a pretty straightforward derivative formula to apply. Okay, so that about does it for this problem, logarithmic differentiation.